Hey guys, welcome back to another episode of the Real Hacker Hours podcast. This is basically where I just do the normal work I would in side projects. I just hit record before I do it. Today we're going to continue looking at Postfix, and what my objective is for today is to hopefully either fully or partially enumerate the attack surface for Postfix, and let me explain what I mean by that. Um Ideally, I want to know what are the various different potential ways we could attack postfix and find a bug. Um, I know the first one that comes to mind with postfix is probably SMTP. However, one thing about this, postfix is an open source software, so anyone can look at it. And typically, since bugs, you were looking at software, you don't create bugs, you only find them. One thing that can help if you look at a target that less people have looked at, it can help with finding bugs since less people have attempted to find bugs in that. So what I'm hoping to do here is ideally start looking at some of the more obscure parts of postfix. So what I'm going to first start doing here, postfix operates with all of these binaries. They make up postfix. What I'm first going to do is just kind of make a list of each of these and just quick Google oh hey Anvil, what does Anvil do? I don't know. So yeah, I'm gonna go ahead and do that. I'm gonna pause the stream while I do it so it's not just 20 minutes of me Googling stuff. Also, one thing my smooth brain just found out, for all of these different binaries like cleanup, discard, Anvil, there are man pages for all of these. So that would probably help out a lot. Okay, so I'm back. As I was going through and making this list, I got to one thing that really piqued my interest, and that is DNS is in postfix. Oh, well, it has a DNS binary. What that's doing, I'm not quite sure. It could just be handling the process of making DNS requests. So it could do stuff like, oh hey, I'm sending a I need to forward this mail to domain X. I need to be able to look up what that is, or something like that. Or it could be its own DNS server implementation, which would be really interesting. At least from my perspective, reason for that being is when I think of the primary purpose of postfix is to be a mail server. So for it to have a DNS implementation on top of that, that's not something I'd personally expect. So let's try looking at it a little bit. Also DNS Blog, what that is from what I've seen from the main page, looks like it's pretty much just a some sort of access control list for the DNS lookup service. I'm assuming that's what DNS does. Also, another interesting thing I'm seeing here. As a part of when I compiled postfix, DNS itself was not automatically compiled, but DNS Blog was. So cool. Let's just start kind of looking at. Well, first, can we compile this? Okay, it's probably the make files. Where does this output to? Is there a directory here? Oh, this is a really fun make file. So I'm looking for right now a directory where outputs it because I tried running make to compile the binary, and it said it's already compiled. Partly what happened. Actually, reason why it says that each of these directories here, they all have here. They all have an individual make file that when you run make in the larger directory, it'll just go through and compile it for all of the smaller ones. So, but yeah, getting back. first off, I want to see if I can't compile it. It says it's already compiled, so... Well, yeah, right now I'm looking for like an output directory to see if it like compiles and places it in a specific directory. It's probably going to be... How many lines is this make file? 400, not that bad. I'm just going to go through it line by line. Type. Those are compile arguments. Debug options 1. Library soft. Show sources objects. Oh wait. One thing that it might be doing here that I just realized. So most of these utilities here, they compile to actual binaries like Anvil. You can see the Anvil binary right there. SMTPD actually compiles to SMTPD. Looking at DNS, however, we see a lot of shared object files, .o files, and I was looking at the yeah, here we see that, so it might not be compiling to one specific binary, but let's keep looking. Test DNS lookup. Okay. Do we have test DNS lookup.c? Okay, we see source code. Can we just compile that? Test DNS lookup. No. Okay. DNS lookup. I'm just gonna briefly take a look at some of these source code files. Let's look at DNS lookup. What does this do? Resource record memory and list management. Fill in the. Hang on 1 second. Is Postfix running? Let me start Postfix. One thing I'm kind of wanting to see here, Postfix start. I'm wondering if in Postfix or one of these modules, if it has the code for the DNS that we're seeing here loaded into memory. So I'm just going to quickly look at GDB. Okay, let's try to disassemble this function. Can we? Nope. Do not have that. Do we have any like DNS type modules loaded? Nope, only postfix master and nothing else. Cool. Detach. Cool. Let's check these other. Well, no, that wouldn't have it. I just thought of one easy way that we could check, definitely, if this is a module that's loaded into other modules. We could just do a grep. Okay, we see it's called an SMTP connect. It's called a lot in DNS. SMTPD. There. DNS. Okay, so we're all seeing that the functions are called in other ones. So what I'm thinking this is it's just DNS is probably just other modules that are then loaded in by other actual executables that we're seeing here, and then that code is used. So okay, that's cool. Next up, what is DNS Blog? Let's take a look. It's only one source code file, shouldn't be that much. Postfix reversing. No, not there. Postfix. Source. Huh, okay. DNS Blog. Okay, main functions right here. Call single server main. See mail server timetable post. Okay. Perform action for a client. So yeah, we see. Actually, hang on 1 second. Let me look at this. Looks like here, like the main functions where the work actually happens are DNS block query and DNS block service. A new service arc. Let's see what this does. Client stream. Look like it's doing a lot there in terms of actually like processing our packets. Let's look here. Reverse the. Okay, cool. So this looks like where it's actually checking the address. It okay reverses it. Take on the RBL domain name. Okay, it concatenates the domain name to tackle the RBL domain name query, the DNS for a record. Turn the lowest. Yeah. What it's looking like, yeah. So what is DNS Blog? DNS Blog, the purpose of it is to act as like a sort of like a access control list for like what DNS lookups are allowed. I'm not sure that's probably from the perspective of DNS calling outbound. That being said, what it's looking like this code is doing here is just checking the looking up if the domain name is allowed, I think. DNS lookup X, we return the lowest TTL. Okay. Skipping reply record. Okay, first off, and see some string concatenates here. Query. What is query? I'm gonna start looking to see if there's any like, since the code here is fairly small, I'm just gonna look and see if there's anything interesting. Concatenate, that can write an arbitrary amount of bytes, so I'm kind of curious what vstring reset. What is this? Wait, static vstring. Static, so we won't allow. Okay, cool. So apparently, looking at here, for some reason, the strings that they're using are not typical, like, appear to be something special called v-strings. What a v-string is, I don't know. But it says we don't have to allocate in free on every request. Now, that seems interesting to me. Reason for that being is if it doesn't allocate in free every request, it might be a static size that we see, and if it is a static size that we can then run concatenate on, that might be something interesting. I don't know. There could be like there could be a bunch of security checks and places I haven't looked yet that would completely prevent any possible issue, but let's see. vstring.h. I haven't dealt with vstrings before, so it might be a postfix specific thing, or it could be part of C. vstring. GCCs. Okay, so it looks like it is like one of the standard data types. I'm going to pause this for a second while I read up on the vstrings. Okay, so after a little bit of Googling, effectively what a vstring is, it's like a C++ basic string. Effectively what that means is it's sort of like a Python string where it like manages its own memory. As long as you're using like vstring functions, it should just arbitrarily grow the memory as it needs to. As such, unless if my understanding of that is correct, unless if there's like an actual bug within like the actual like library implementations of those things, these should not lead to an overflow since query, at least here. So we see query is reset. Is this the only time vstring reset? Okay, this is called twice. When's the second time? Result query. What about this? Why is this not reset? Hang on a sec. I'm gonna look up some man pages of vstring. Allocate. Oh, no man page for that? Cool. I guess what I could potentially do, actually here, let me look this up. What is vstring alloc? Postgre. No. I'll probably just write just fuzz this to see if it can do anything. So, okay, the attack surface pretty much is just DNS queries being sent here. How they're sent, I'm not sure. Let's figure that out. I'm going to Google how to use Postfix DNS Blog. I'm going to pause this as I read through Google. So apparently what DNS Blog is it itself doesn't handle the process of actually handling access control stuff. That is Postscreen. It just logs it. So Postscreen is running. So one thing we're going to have to do is enable Postscreen running in order to get DNS Blog to run. So let's go ahead and do that. So we need to edit. I'm just following a guide right now. Let's edit this file. Let's go down to Postscreen. Oh, apparently just have to first comment these 4 lines. Wait. So T. Yeah, these 4 lines. For a second, I thought I made a mistake and uncommented one more line that I should have. Okay, save and close the file. Apparently, the next thing I'll need to do is add the whitelist and the blacklist postfix. It's so nice having your files and everything compiled and set up to like the standard. That way you can just basically copy and paste from guides. Need to check out the follow. Okay, so we just have to append these 2 lines. Postscreen access list equals permit. By the way, the guide that I am following is this right here. Okay, continuing. Permit Wait, what am I doing? I just copy and paste this in. And we do that. Okay, next we're going to check the values for this network that we just had. Okay. And okay, so right now, those are the 2 IP addresses listed. I get the feeling that, yeah, so it's basically just localhost is allowed. And if we wanted to add additional IP addresses, we could just edit that file. And let's add a few just for the fun of it. So 127.0.0.2. Okay, cool. And can't open for writing. Oh, need to edit it as sudo. Okay, cool. Have that. Now let's try restarting Postfix. I'm gonna check the status. Is it okay? It's running. Okay, see that it is indeed running. Let's see about Postscreen. Postscreen is not running. So okay. There's more to this guide, so I'll probably just follow through and postconf itself also. Gonna pause this for a second while I read. Okay, cool. So I'm back. Now, one thing I'm curious of is actually. Oh wait, no, that's the log file. I meant to look through the processes. So I know right now we don't have SMTP. That process is not spawned until we actually start sending emails. Kind of curious if Postscreen is like that too. So I'm just gonna go ahead and kick off the SMTP fuzzer I have and see what that does. Okay, cool. So you see a few more. Postscreen is now running. That is cool. We got that. Along with SMTPD, I am going to go ahead and attach to it. It is 4155. Okay, we have successfully ran and attached to Postscreen. Cool. Now, let's take a look at the source to see exactly what we're dealing with here. No, this is Postfix, not Postscreen. Script. See. Oh, this is. Okay, so it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different files. Okay, cool. Let's look at it. Postscreen. Let's see. About 1,000 file. No, 1,000 lines. Made. Okay, it starts a giant list. This is probably just going to be the startup to a server. Event server made. I wonder if event server made, if that is part of some library or that's just like a postfix defined way of starting servers. If I had to put my money, I'd probably say postfix defined way. Actually, let's check just for curiosity. Okay, it looks like, yeah, it's from here. We see if what looks like a function declaration right here. So it is postfix defined. Cool. Good to know. Server exit, server watchdog. Wait, are all of these pre-jail init stir table, bool table, raw table? Does it like declare server solitary? Is it just declaring some like effectively data structures that the server's gonna have? I don't know. I'm looking at this too much. Cool. Statistics. Handle new client connection. Okay, this probably is a good place to start. Let's see. Can we break on this in the debugger? Where's the debugger? Debugger's right here. Cool. PSC service. Where input starts probably a good place to look at. Okay, the program terminated. That is unfortunate. Look up the remote SMTP client address and port. Okay, so there definitely is a good bit of functionality with this here, and I am interested into seeing what it does. Granted, it is still at the end of the day effectively handling SMTP traffic flowing through. And I just realized I'm getting a bit more into the weeds than I intended on right now. My purpose is to effectively just enumerate the attack surface. So I'm just going to go ahead and jot this down for Postscreen and then move on. Those access control over. Cool. So this has been going on for about 30 minutes. I'm going to end it off here. Thanks for watching.